Today we are reviewing the idea of zero and negative exponents. Hopefully for the majority of you, you can remember from last year the difference between them and what they mean. Okay, a zero exponent, anything to the zero power equals 1. No matter what it is, the part that it has the zero exponent will be equal to 1. So 5 to the 0 is 1. The quantity negative 2 to the 0 is 1. And it's very important to notice this negative is inside of the parentheses. The quantity 1/3 to the 0th power is also equal to 1. And if you'll also notice, this fraction of 1/3 is inside of the parentheses as well. A negative exponent then tells you the term is in the wrong position. By wrong position, we mean numerator versus the denominator. So you have to change it, and once you move it, you lose it. So if it's in the numerator, you move it to the denominator, and it's no longer negative. The same is true moving it the other way. So if I look here, 6 to the negative 4, I can put it over 1 to make my fraction. Currently, this is the part with the negative exponent. It's in the numerator, so I need to move it to the denominator. So I move it, I lose the negative, I have nothing left in the numerator, so the numerator is now 1. So my answer then written with positive exponents is 1 over 6 to the 4. The quantity negative 8 to the negative 1st. Again, this has a negative exponent. The entire thing is negative, so I'm going to circle everything. I need to move it and lose it. So I move it to the denominator, and then I lose the negative. Anything to the first power is the exact same thing, so I could write it like this. Either one of these would be correct. Okay, so now we look at example 1. It's just simplifying the power. So if I look here, the first thing I notice is a negative exponent. I'm going to write it as a fraction. I always circle or highlight the part with the negative or 0 exponent. I need to move it and lose it. I move it to the denominator, lose the negative, and I have 1 over 4 to the 3rd. B then, this is to the 0 power, anything to the 0 power equals 1. Very simple. Now we're going to get where there are more than one part in each problem. So example 2 gives you an expression to simplify. This is where I think it's going to be important for you to circle the parts that can simplify. The x negative 3 is currently the only thing with a negative exponent, so I'm going to circle it. It has a negative exponent because it needs to be moved. So the 4y did not have negative exponents, so it stays in the numerator. The x to the negative 3rd had a negative exponent, so I need to move it and lose the negative. So my answer would be 4y over x cubed. On the second one, again, I notice there's a negative exponent on the w, so I need to move it and lose it. I need to move it to the numerator. There's nothing left in the denominator, so I could write this as w to the 4th over 1, which is simply just w to the 4th. This one has several different parts to it. First of all, I'm going to notice s is to the 0 power, t is to the negative 5th power, and 2 is to the negative 1st power. So if I switch colors here just so you can kind of see my movement here. S to 0 is 1. 7 times 1 is simply 7. I need to move this one down, and I need to move this one up. So this is going to be times 2. If I move it, lose it, 2 to the 1st, over m squared stayed because it didn't have a negative exponent. T to the negative 5th needs to move it, lose it, t to the 5th. I can simplify the numerator. 2 to the 1st is 2, so 7 times 2 is 14 over m squared t to the 5th. And that's my final answer. Example 3 here has you evaluating an exponential expression. Evaluate just means to simply get what it equals once you sub in some numbers. The first thing I would notice is I would simplify the expression This has a negative exponent, so I need to move it, lose it. So I rewrite this. 3m squared stays put because they had positive exponents. T had a negative exponent, so I move it, lose it. And now I'm going to sub it in. It says m is 2, 3 times 2 squared, over t squared, and t is negative 3. So 3 times 2 squared is 3 times 4, over negative 3 times negative 3, which is 9. If you put this part on your calculator, you have to make sure the negative is inside the parentheses. Otherwise, it would give you a negative 9 as your answer, which is not correct. 3 times 4 is 12 over 9. And if I go ahead and keep simplifying, that would be 1 1/3. So that's my final answer because it said to evaluate it, which means to get what it equals numerically. Okay, our real world story problem. This section has the following. A biologist is studying green peach aphids like the one shown. In the lab, the population doubles every week. The expression 1,000 times 2W models an initial population of 1,000 insects after W weeks of growth. Evaluate the expression for W equals 0. So again, evaluate means to get what it equals. So I have 1,000 times 2 to the W, but they say W equals 0. Anything to the 0th power is 1. So 1,000 times 1 is 1,000. And then it says, describe what the value of the expression represents in the situation. This gives us the initial population since the week equals 0. So this is our starting point. When we started the experiment, there was already 1,000 insects. B says evaluate the expression for W equals negative 3. So I'm going to replace W with the negative 3. If I do that, I have 1,000. That negative sign is telling me it's in the wrong position. So I move it, lose it. 2 to the 3rd is 8. 1,000 over 8 is 125. Then describe what the value of the expression represents in the situation. Remember, weeks is, W is weeks. If it's a negative 3, that's telling me 3 weeks from where we started. So 3 weeks before the population hit 1,000, the population was 125. Okay, if you go ahead and you turn your page, you have your quick check questions and check the schedule then for your assignment.